In this video, I will be solving homework 5 on project management. And this video is intended to be a resource for you. If you get stuck on a question, you can't figure it out, I do recommend that you first try to solve the homework on your own. If you get stuck, refer to the examples in the slides. And if you are still stuck, you can ask me questions, or you can watch this video. Okay, let's start with the electric motor scenario. So we have received an order for a specifically designed electric motor, and we have to do a project to create this motor. So maybe we've received some specifications, and now we have to do certain design and engineering related activities to make the motor. Okay. We have activity information right here, and we need to identify in question 1 the critical path. Okay. So we need to draw a network diagram to start off with. So I'll do everything in Excel. Okay, so we can start by just writing start. Okay. And then from starting the project, we can do any activities which do not have a predecessor. So that's A, B, and C. They have no predecessor, so they could be done right away. Okay, so let's do A, which takes 4 days, B, which takes 7 days, and C, which takes 5 days. So each block or cell is representing an activity. Right, and we can add lines to show, we go from where to where. So you can do start, you can go from start to A, right? You can go from start to B, and you can go from start to C. Okay. After that, we can now do any activities which depend on A or B or C or any combination of these three. So let's look at activity D. It depends on A, so we could do D next. Okay, so D, which takes 6 days, can be done next. Look at the activity E. It only depends on B, so it can be done after B as well. So E, which takes 3 days, and then F depends on C, which takes 11 days. So we can draw these activities on our map. And now you have to do A to do D. And so the arrow will start at A. So once you've done A, now you can do D. Okay. Same thing for B and E. You have to finish B before you can do E, and so you can draw the arrow here. And then once you've done C, you can do F, so we can draw the third arrow here. Okay. And now we'll look at G. G depends on 2 activities, D and E. So once you do D and E, you can do G, which takes 4 days, and H depends on F and G. So you can do H, which takes 3 days after you've done F and G both. So we draw the arrows for G first. The arrows will go from D and E to G. Okay, and then from E to G. And now you need to have done F to be able to do H, and you need to have done G to be able to do H. Okay, and there's no other activity. Once you finish H, you're kind of done. So if you want, you can draw finish node or end node. You can call it finish or end, and we can draw an arrow there. Okay, So this is our network diagram, which represents the information given in this table. To find the critical path, there are two ways. We can find the early start, early finish, late start, late finish times of each activity. We can find the slack. All activities with a slack of 0 are on the critical path. We will take that approach in this problem. Okay. For now, we will take the other approach, which is to list all the paths and then find the longest path. So how many paths are there? Well, for one, we have a path which goes from start to A, D, G, and H. So we have A, D, G, H. Another path we can do is to go from B, E, G, H, B, E, G, H. And another path we can do is C, F, H. Okay. Let's see if there's any other path. C, F, H is done. A, D, G, H is done. B, E, G, H is done. So these are our 3 paths possible. Now to find how long each path takes, you have to add the time of the activities on the path. So A, D, G, H will take 4 for A, plus 6 for D, plus 4 for G, plus 3 for H, 17 days. Similarly, B, E, 7 for B, 3 for E, 4 for G, H for 3 will take also 17 days. Okay. And then CFH will take 5, 11, and 3, 19 days. Okay. So clearly this is the longest path. Okay. And so we'll look at the answers, and then this is the answer. So it says only select one option, so make sure you only select one option. Right. And we know how long the project will take. It will take 19 days because the longest path is the critical path, and by the time you finish the critical path, all the paths are done, so you're done with the project. How long will the project take to complete? That is the duration of the critical path, so that'll just be 19 days. Okay, and that's it for the first scenario, and then we get to the second scenario on advertising campaign project. Okay. So again, we have some project, we have listed the activities here, and this time we don't have just one time for an activity, we have 3 times. 3 times means that we don't know precisely how long an activity will take, but we can give a realistic time, which is a most likely time. So most likely it will take for whatever is weeks, so everything is given in weeks. So most likely activity A will take 4 weeks. Worst case, if things happen, there are delays, something like that, it can take up to 7 weeks. And best case, if everything lines up properly, in ideal conditions, it can take up 1 week. The actual time it takes when you actually do the project will be some number between 1 and 7, with a high chance to be 4 or something near 4. Okay? So that's how we read these times. Same thing for all the activities. So we need to copy this table into Excel. Okay. And then we can move this column to the side because we need 2 additional columns, which is the expected time and the standard deviation of time. Okay. And how do I know we need these columns? If you go over the slides, you'll know it's explained in the lecture. So if you go to the slides, so this is the one, optimistic time, most likely time, pessimistic time, and then it tells you that to do this analysis, you need to find the mean time or the average time and the variance as well. Okay. And so you can see here in this example, I have the expected time, which is the same as the average time, and then I have the variance. Okay, so I'm going to change this to variance. Okay, the formulas are given on this slide. So the average time is the optimistic time plus 4 times the most likely time plus the pessimistic time, all divided by 6. So this will be this plus 4 times the most likely time plus this one divided by 6. So this is a weighted average. So I'm weighting most likely times a lot more, and I'm giving just a small weight to this and this. So these two get a weight of 1, and the most likely time gets a weight of 4. The total sum of the weights is 6, 1 plus 4 plus 1, and so this is like a weighted average. Okay, and so we drag it down and we find the expected times. Now for variance, it's the difference between the optimistic and the pessimistic time divided by 6 squared. Whether you do a minus b or b minus a does not matter, because the square will take away the minus sign anyway. Okay, so we will do 2 open brackets, and we can do b minus a or a minus b. It gives you the same answer. The difference between the optimistic and the pessimistic times divided by 6. And now this is why I need the outer bracket, because I need to square the whole thing. So I do shift 6 to get the hat, and 2, that's how you square in Excel. And if you didn't have this bracket here and you just put 6 hat 2, it will just square the 6 and not the top part. You want to divide by 6 first, which is why you have the outer brackets, to make sure that happens, and then the result needs to be squared. Okay. And so you get the variance for each activity. So, expected activity 1 is expected to take 4 weeks with a variance of 1. Expected activity B to take 5.5 weeks with variance of this, and so forth. Now we can go ahead and draw the diagram, but the diagram is kind of already drawn for us here, right? We do need to we are going to solve for the critical path using the forward pass and backward pass to get the slack values, which is the method shown in the slides right here. How you do the forward pass, backward pass, and how you identify slack, which is S, and how you identify the critical path. Method 2 using activity slack. So we're going to do that now. And if you look, we have already finished some questions. So expected time for activity B, that will be this column. Expected time is the weighted average. That 5.5 would go here. And variance for activity C, I'll take activity C, find the variance, 0.25, and so forth. So a bunch of questions about the expected times and variances. We have all the information here to answer them. And then we get to the critical path question. Okay. So let's put this diagram in Excel. I'm not going to draw the start and finish nodes, or maybe I am. So let's do that. Let's draw this diagram here. And first you get to A and B. And now I'm going to need a cell above it for the early start, early finish times, a cell below it for early start, early finish, and late start, late finish. And so I'm going to need some more space than last time. Okay, so I need A and B. So let's put A here, which takes we have the duration up here, so I'm not going to write the duration here. And then let's put B here. Okay, these two activities have no predecessors, so you can start the project off with them. As soon as the project starts, we can move to start these activities. Then D depends on A, so we can put D here. And C depends on B, so we can put C here. Okay. Then E depends on A and C, so A and C will both lead to E. Okay, so let me actually start drawing the arrows now before I forget what leads to what. Okay, so start, we go to A, and then start, we go to B. Okay, and then A goes to D. B goes to C, and then C goes to E. This is all coming from this information, right? How do you know C goes to E? Because A and C must be done to do E. So from A and C, you'll go to E. A also goes to E. Okay. And just replicate this kind of picture. And then F depends on B. So we can put F maybe down here. F depends on B. What else? G depends on E and F, so we could put G here. Okay, so E and F lead to G, and then that's it. Then you get to finish. Okay, now notice that we have, maybe it's easier to do it here to show you guys, E leads to G. Now G will go to finish, obviously, okay, but not only G will go to finish, okay. And D, you cannot just stop after D, you have to end. That's the reason we draw start and end nodes, that all paths must start from start and end at finish. You can't just go A, D, and then just stop. You have to go on all the way to finish, or go to some other node which goes on all the way to finish. So we can't leave nodes without anything coming out of them, just to complete our paths. I mean, you could, and you would just know, okay, after AD, then this path is finished. Like logically, you would know that. But to avoid making a mistake, it's better to represent it graphically by drawing a line like this from D to finish as well. Okay, maybe I should move finish up here. It'll be a little bit better, and then this will go from G. Okay, so you can see the structure is the same as the structure here. E goes to G to finish, D goes to finish. So we replicated that. Now we have to do the early start and early finish times. And so A can start as early as time 0, right? Because as soon as you start the project, you can start A. Okay, and then when does A finish? You look at the expected time. So the expected time for A to finish is 4. Okay, and so the first number is early start, and the second number is early finish. Early start means the earliest you can start A. Similarly for B, early start will be 0, early finish will be 5.5, because on average B takes 5.5. This comes from right here. Okay. Now D depends on A. So when's the earliest D can start? D cannot start before 4 because A finishes at 4. If D cannot start at 3, for example, because A is not done yet. So D can start at 4, and then we take 4 plus, how long does D take? D takes 12 days, so it can end at 16. Okay, because it takes 12 days, starts on 4, at the end of 4, so basically beginning of 5, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, it ends at 16, goes 12 more after 4. Okay, and then I can go on to C here. C can start at 5.5, and then C takes 3.5 days, so it can stop at 9. Okay, this is called the forward pass. We're going from start forward into the graph to write all the early start, early finish times. F can start again at 5.5 after B is done, and F can stop after 9 days after that. So that's going to be 14.5, 5.5 plus 9. 9 came right from here, the expected time for F. Okay, we use expected times to do our forward and backward passes. Okay, so we're going to use these times to determine our forward pass and backward pass. Now that we have A and B, A and C have been marked, we can talk about E. So can E start at 4 at the end of 4, at the end of week 4? No, because C is still going on. Both A and C need to be done for E to start. So we pick the higher of the two numbers. So Okay, so basically, once we get to E, you have to look at the 4 and 9, and E can only start at the end of week 9 when C is done, because even if A is done, you cannot start until C is done. Then you take 9 and you add 6.5 to it, you get 15.5. Then this gets 15.5. And if you add 4.5 to it, you get 20. So 20 is the project duration. So G must finish by week 20. So if it must, that's the late finish. Otherwise, if it finishes beyond 20, it will delay the whole project. And 20 minus 4.5 gives us the 15.5. So the late start for G is 15.5. Now we can work backwards. E must finish by 15.5. Right? Otherwise, G cannot start by 15.5, and the late start for G is 15.5. G has to start by 15.5, otherwise we delay the project, right? So 15.5 minus the duration of E, which is 6.5, gives us a late start for E to be 9. Similarly, we can work back from G to F. F must finish by 15.5, otherwise it will delay the start of G. Late start of G is 15.5. So at most F can take up to 15.5. F is expected to take 9. So if you do 15.5 minus 9, you get 6.5 for F. Okay, 15.5 minus 9, the duration of F, gives you the late start. F can start as late as 6.5 and still get done in time for G to start on time. Okay, now we can look at D. D can end as late as 20 and still not delay the project, because we need to get here at 20. So D can end as late as 20, which is the finish time when we got to the finish node, because D and G both have to finish for the project to finish. So there has to be 20, and so D can finish on week 20 and be fine. And because D takes 12 days, you can do 20 minus 12. So D at the latest must start by week 8. So D could start at week 8, finish at 20, and will still be fine. It will not affect the project duration. Okay, now going into C. C has to finish by week 9, otherwise the late start of E will be delayed, which is not good. You don't want to delay the late start, because otherwise project gets delayed. And so if it's ending by week 9 and C takes 3.5 days, it has to start by 5.5, because 5.5 plus 3.5 equals 9. Okay, and so maybe I need to move this down to keep the picture clear. And move this down here and this here. Okay, so the numbers are, there's this gap between the cells, so you can see which number belongs to which activity. Okay, so we're working backwards. So now we can actually go to A. The case of A is curious. Can A finish at week 8, because D needs to start on at the end of week 8? So can A take week 8? Right, and A also goes into E, so A could also finish by 9 and not affect E. So what should we take? Should we take 8 or 9? Does A have to finish by 8 or 9? We always take the smaller number in this case, because if A was to go up to week 9, it would delay D, and then D would start on 9 and end on 21, which would delay the whole project. So we have to finish A by 8, which is the smaller of the two activities that A leads into. And A takes 4 days, so A has to start at the latest by 4 weeks. So A has to start by week 4, at the end of week 4, and so 4 to 8 is the late start and late finish for activity A. Similarly, C leads into two activities, so we look at the late start of both and we take the minimum. So B has to end by 5.5, otherwise it will delay activity C. And because B takes 5.5 weeks, it has to start at time 0. And now we have, 4 numbers for each activity. Top left is early start, top right is early finish. Earliest start, it can start at this time, earliest finish is this. Bottom left is late start, the latest it can start is this, the latest it can finish is this. Okay. And so now we can compute slack. Slack is late finish minus early finish. Or you can also do late start minus early start. It's going to give you the same difference. So the slack for A is 8 minus 4, which is a slack of 4. Okay, for activity A, 8 minus 4. The slack for D is also 4 because 20 minus 16 is 4. Okay. The slack for E is 0 because 15.5 minus 15.5 is 0. Okay. The slack for G is also 0 because 20 minus 20, this late finish 20, early finish 20, 20 minus 20 is 0. The slack for C is also 0 because 9 minus 9 is 0. Slack for F is not 0 because the late finish and early finish times are different. That's 15.5 minus 14.5, which is 1. The slack for B is 0 because 5.5 minus 5.5 is 0. So now we're going to color all the activities with a slack of 0 in a different color. Because these are critical activities. If any delay happens to these activities, the whole project is delayed. Okay, so now this is our critical path: B to C to E to G, and then to finish. And the duration of our project is 20 weeks. And activities, B, C, E, and G must be managed carefully because any delay on these activities delays the entire project. So if we go to the critical path, let's see if BCEG is an option. BCEG is an option. It's this option right here. Okay, and so that will be the critical path. What is the expected duration? That's the duration of the critical path. So the activity G ends at time 20. We get to finish. So the duration is 20 weeks. Okay, what is the probability to finish the project within 23 weeks? So our expected finish time, is 20 weeks. Variance of this, what is the variance? Because expected finish means it's not guaranteed to finish in 20 weeks, right? So it's not guaranteed. So how did we get 20 weeks? We follow the critical path. Critical path takes 20 weeks, right? So the variance, to get the variance, we have to add the variance of the activities on the critical path. So we take the variance of B, which is 0.694, plus I'm going to take the variance of C because that's the next activity on the critical path, okay? Plus the variance of E. Notice I'm skipping D, I'm skipping A. Why I'm skipping A and D? They're not on the critical path. So take the variance of E, which is 2.25, and then plus I take the variance of G, which is 0.694. When I sum up the variances, I get the total variance. And now I need to find the standard deviation because the normal probability formulas in Excel require standard deviation, not the variance. So I take the square root of the variance. Okay. You cannot take standard deviation here and just add standard deviations. You have to find the variance and add variances. If you add standard deviations, you'll get the wrong overall standard deviation and your answer will be incorrect. So make sure you stick to variances and add up the variances for the critical path and then take a square root to get standard deviation. Okay. So we expect the project to finish in 20 weeks with standard deviation of 1.972. So now it's easy to find what's the probability that the time taken is less than or equal to 23 weeks. That is going to be norm.dist. This returns the probabilities under a normal distribution. Now, why am I assuming a normal distribution? Because my total time is a sum of multiple things. And when you add a bunch of things together, it doesn't matter what the individual distributions are. The summed up thing is going to be normal by the central limit theorem. Now, I'm only adding 4 activities. So with 4 things added up, as long as the activity times are normalish or bell-shaped, we'll be fine. But if the activity times are very skewed, we may not be fine, but this is an approximation, will be approximately fine. So the more activities you add up or the more bell-shaped the activity times are, the tighter or the more accurate this approximation from central limit theorem will going to be. So anyway, we're going to always assume central limit theorem holds, because we're not going to get into the complex case of beta distributions and the total not being a normal distribution. You can use simulation to answer these questions in that case, but we're not going to do that in this course. So you just want to assume the normal distribution for this total time of 20 weeks. Okay, so we need the probability that this time is less than or equal to 23 weeks. On average, it's 20. And the standard deviation is 1.972, and we do want the cumulative, the area under the normal distribution curve. So using this formula, norm.dist, the number 23, that's the cutoff. I have to be below this cutoff, so I do this. Okay, this is the probability you'll finish within 20 weeks. What is the probability that it takes more than 23 weeks? Well, that's just going to be 1 minus that, because I could ask you that in a question too, right? So 23 weeks is our deadline, let's say. So what's the probability we go past our deadline? Well, that's the 1 minus the probability of finishing within the deadline. So that's about a 6.4% chance, or 0.064 probability. Okay, so we need to put in the probability here to 3 decimal places. So you can just use these to show 3 decimal places, 0.936. And so that would be the answer to this question. Okay, using the norm.dist formula with true at the very end to get area under the curve. Okay, so that is the end of this homework, and so hopefully this was helpful.